Okay, so this is a little bit more work with identities, and again, there's always numerous ways to solve these. I'm going to use the identities here in the tables. See the way I have cos squared a? I'm going to use this identity, so I'm going to replace cos squared a with that, and I'm going to replace sin squared a with that one. So that's what I have, and now why am I picking those ones? Well, you see I have a cos 2a here, so hopefully it'll work out correct. Now, so try to show that the right hand side can be written the same as the left hand side. So cos 2a equals, now remember cos squared a equals a half times 1 plus cos 2a. Now put in your minus, and remember sin squared a was a half times 1 minus cos 2a. So just multiply out the brackets. So a half times 1 is a half. A half times this is cos 2a all over 2. Multiply anything by a half, it's the same as dividing by 2. Minus a half times 1 is minus a half. A minus by a minus is a plus. And that'll give me cos 2a again over a half. Now look at this, I have plus a half and I have minus a half, and then I have cos 2a over 2 plus cos 2a over 2. Well, think of that as, so you have a half plus another half, so that gives you cos 2a. So the left hand side equals the right hand side, QED. Now the second part, the difficulty is getting the equation set up at the start. Now you're working in radians here, very important to note that. So theta is in radians. So you're dealing with the kind of a sector of a circle. So I'm just going to show you this formula. It's not the most commonly used one, but it's on page 9 of your tables. Now, the area of a circle when you're given theta in radians is that, as opposed to pi r squared. And the length of this sector here, so see this little sector, if you want to calculate the length of that sector, it's r times theta. So that's the length that we're going to use, and that's the formula that we're going to use. Now, the diagram shows part of a circular end of a running track with 3 lanes shown. The centre of each of the circular boundaries of the lanes is at O, so there's O. Kate runs in the middle of lane 1. From A to B is shown. Helen runs in the middle of lane 2 from C to D is shown. Helen runs 3 metres further than Kate. That's a key statement. Now each lane is 1.2 metres wide, find R. So we're going to have the length, we're going to need an expression for the length of this arc. So maybe I'll colour code this. So the length of this arc, need an expression for it. So remember earlier from the formula I told you that the length equals r times theta. The length of the arc is r multiplied by theta. Now, so the distance that Helen runs is 3 metres further than Kate. So say if you have Kate here and then you have Helen. The distance, so this distance here, I'm just going to let this be r. So sorry, so there's her. And I'm going to let Helen be this blue distance here, okay? So hopefully that's coming up okay in the video. Now for Kate, I'm just going to let the radius be r. So the distance from there to there is r. I don't need to worry about that, just doing it from there and adding on 0.6. Don't need to worry about that. Just do that's the first radius. And the radius for Helen, because each running track is 1.2 metres wide, Helen is 1.2 metres, her radius is 1.2 metres greater. Now, the distance that Helen runs is 3 metres further. Now, I want an equation here. So, in order to make the distance that Kate runs the same as the distance that Helen runs, I have to add 3 to Kate's distance. Because in order for them to be the same, I have to give Kate 3. It's a bit like if you had €3 more than someone else, in order for you to have the same amount, I'd have to give them €3. So that would mean now that the length of the arc that Kate runs from the formula is r times theta. Now, Helen's radius is r plus 1.2, so the distance that she runs is, so if it's r times theta, or r times the angle that she runs, remember, or sorry, her radius, sorry, so yeah, it's r times theta, sorry, so just the radius that she runs is r plus 1.2, and then times that by theta. So that's the length of the sector Kate runs, that's the length of the sector that Helen runs. Helen has a radius of 1.2 more, so that's why we have r plus 1.2. Now we're just going to solve this lovely little linear equation. Now r times theta is r theta, and 1.2 times theta is 1.2 theta. Now we have an r theta on both sides, so they'll cancel with each other. So I've just got 3 equals 1.2 theta. So just take the 1.2 across and divide or whatever, and theta gives you 2.5 radians. So in setting up the equations, the important thing, so just watch it a few times and hopefully you'll get the gist of what it is.